Good evening, everyone, from London. Welcome to this event. I am Sina Muradi, CIB Program Manager and Lecturer in Project Management at University College London. I will be chairing this event today, in which the winner of CIB Best Doctoral Dissertation Award 2024 is to be selected based on the finalists' presentations and the decision of the evaluation committee. So without further ado, let's proceed with introducing our finalists and respected judges. Respecting the seniority of our judges, I will start first by introducing them. It is a great honor today to have Professor Kalle Kähkönen from Tampere University, Professor Cathy Michel from University of Cape Town, and Associate Professor Jeremy Gibbert from the University of Witwatersrand as the referees in this competition. I truly appreciate their positive response to my invitation for joining the evaluation committee for this award. Now it is time to introduce our finalists for this award in the order based on which their 6-minute presentations will follow. Dr. Hongying Zhao, nominated by CIB Student Chapter at RMIT University. Dr. Ania Khodabakhshian, nominated by CIB Student Chapter at Polytechnique di Milano. Dr. De-Graft Joe Opoku, nominated by CIB Student Chapter at Western Sydney University. Dr. Olufisayo Adedokun, nominated by CIB Student Chapter at Newcastle University. And Dr. Oluleye Benjamin, nominated by CIB Student Chapter at Hong Kong Polytechnic University. So let's proceed with the first presentation by Dr. Hongying Zhao.
Hi, everyone. Good morning and good afternoon. I would like to share my screen. Could you? Yeah. So could you see my screen?
We can see you only, not the screen. You were in the... Okay, try again, please. Just...
It's, I think...
It's some... Yes, we can now see. You just need to put it on the presentation mode.
Okay. So you could still see my screen, right?
Yes, we can.
Yeah, okay. So I will just start now. Good morning and also good afternoon, everyone. I'm Hong Ying from RMIT University, School of Property Construction and Project Management. Today, I will present my PhD research on the building integrated photovoltaics in the urban environment. Here on the right is a photo I took of Melbourne, a city known for its vibrant and beautiful urban environment. But this cityscape also highlights challenges that many cities are facing now. Its growing energy demand in increasingly complex urban structures. With limited roof areas in high-rise buildings, traditional rooftop solar panel could be strict. This is where building integrated photovoltaics, or BIPV, comes into play. So the building facade could have the dual function, which serves the structural elements and also the energy generator, and they are customizable and seamlessly integrated in the urban environment, and also they are market ready with a variety of available products. However, despite the great potential of BIPV, several challenges hinder its widespread adoption. Through our literature review, we have identified the key gaps. For the urban environment, the complex urban structure makes the evaluation difficult. For the evaluation method, there is a lack of the comprehensive method for assessment of vertical facade and also the BIPV potential. And also, urban planner lack tools for a quick, accurate assessment, and also the public awareness is remain low. So, urban environment, although complex, they offer a lot of data. With the development of AI, it presents an opportunity where we can process large urban data set for a smarter and quick assessment. So in light of these challenges and opportunities, in this research, we aim to investigate the energy, economic, and environmental potential of BIPV facade in the urban environment through a machine learning-based urban morphology method. And four objectives are proposed, namely establish the conceptual framework, develop the simulation, and also prediction model to evaluate the different potential. Here is our research design, and we focus on the Melbourne CBD, covering a 2,000 by 2,000 meter area with 451 mesh blocks. We developed a machine learning-based evaluation process using the data generated by our simulation method. So we will use the output generated by the simulation method to train our machine learning models, as shown in the figure here. And this is a two-level prediction model where we use 11 urban morphology indicators, and to get the result, or including the shading height, the unshade solar radiation, and also the energy generation. And for the entire study area, there is over 372,000 training samples generated by our G simulation result. So our prediction model can reduce the simulation time from 8 hours to a few seconds while remaining high accuracy. And use this prediction model, we can further generate the result for the economic and environmental potential. For the economic factors, we use a 30-year net present value, the payback period, and also levelized cost of the energy. And for the environmental impact, we consider the carbon emission reduction. And with the potential we have calculated, we want to understand the factor most affect this potential and how to facilitate the decision-making process for urban planning. We conduct the correlation analysis, focus on the north, east, and west facade, the orientation of the highest potential. And for each facade, we identify the most significant correlating factors to inform our clustering analysis. For the clustering analysis, we only focus on the high-level performance mesh block and also the low-level performance mesh blocks, because we want to help maximize the benefit and avoid poor performance in the future planning. Here we compare these two different kinds of mesh block and want to generate decision-making metrics for different orientation and consider different economic indicators. Here shows the details of the urban morphology metrics, but I want to emphasize that our metrics can offer the urban planner with a quick and efficient estimate, and it leads to a practical decision-making process where we can quickly assess the BIPV potential in different urban mesh block, and also we can consider different orientation for the BIPV application, and also make informed decision about the BIPV integration in early stage urban planning, consider the economic and also the environmental benefit.
1 minute
To sum
left.
up, our research contributes include, first, a comprehensive BIPV evaluation framework for the urban environment, and also fast, accurate assessment tool for the urban planning, and also a decision-making metrics for practical implication, and also our research. The result of our research demonstrates the economic and also environmental benefit of the urban BIPV facade application, which lead to boost the investment and the public awareness. Also, we have a scalable AI-driven workflow adopted to other cities. So in conclusion, our research brings the technical evaluation and the practical application, where Although tested only in Melbourne, this methodology offers a powerful tool for the global sustainable urban development. And so our city don't just shout us, they can also empower us. Thank you for your attention, and I'm happy to answer any question. Thank you.
Thank you very much for your presentation. So let's continue with the second presentation by Dr. Ania Khodabakhshian. Ania, you are.
Sorry, thank
Yes.
you. Okay, let me just quickly share. Do you see my screen?
Yes, very well.
Okay, perfect. Hello, everyone. I'm Ania Khodabakhshian from Politecnico di Milano, and I'll present my PhD dissertation, Machine Learning for Risk Management in Construction Projects. Risk management is a critical yet ineffective aspect of construction projects. Traditional methods rely on experts' opinion for risk assessment, which are subjective, experience-based, and inconsistent, and struggle to adapt to dynamic project changes. This can result in delays, cost overruns, and safety hazards. My key objective was to address these limitations by applying advanced machine learning methods. Excuse me, by applying advanced machine learning methods to automate risk management process and minimize manual effort and human error, overcome data limitation prevalent in construction industry, deliver accurate and objective risk assessments, and gain trust from stakeholders by ensuring transparency of machine learning models, and hence transform risk management into a data-driven practice generalizable to future projects. Machine learning leverages historical project data and collective experts' opinion to integrate project variables like delivery method and budget with risks they trigger, create a risk network based on identified interdependencies between these variables and risks, and output risk probabilities for new projects based on their variables. I explored 3 data-driven solutions to find the most effective one: fuzzy logic models based only on expert judgments, deterministic models, machine learning models based only on project data, and Bayesian networks integrating subjective expert judgment with objective project data. The framework was trained and tested on 44 projects from Jacobs Engineering Group, the industry partner of the research, identifying 65 risks and 46 project variables, which was a limited size of data. To address the data limitation, the dataset was augmented using generative adversarial networks, an innovative method to augment tabular data. The result comparison provided a comprehensive evaluation of each solution's applicability, effectiveness, and the role of frequentist versus Bayesian inference when encountering a limited database. The first solution, fuzzy logic model, uses linguistic terms like low or high to quantify subjective expert judgments on risks. 16 experts evaluated risk qualitatively based on various project variables, which were then converted into numerical probabilities using fuzzification, aggregated through rule-based modeling, and ultimately defuzzified into crisp values ranging from 0 to 1 as the probabilities of the risks. While fuzzy logic enables a comprehensible risk assessment and facilitates collective knowledge transfer, it tends to assign higher probabilities to risks not backed by factual data with a complex rule-based modeling. The second solution, deterministic machine learning models, rely on gradient-based learning algorithms to process large data sets and classify risks as either present or absent, with no probabilities assigned to the answer. To address the data limitation, generative adversarial networks were used to create synthetic data, which doubled the dataset size, improved model accuracy, and balanced the dataset. While these models have advanced learning algorithms, simple pre-processing, and capability of handling complex data, they have low accuracy and risk underestimation in small data sets due to their frequentist inference, are prone to overfitting and lack transparency due to their black box structure, making them less ideal for building stakeholders' trust. Finally, the third solution, Bayesian network, combines objective project data and subjective experts' opinion using Bayesian inference, effectively addressing data limitation. This network consists of a directed acyclic graph linking project variables to risks with a conditional probability table capturing their causal relationships. Experts defined the structure and initial probabilities, which then were updated with augmented project data. This allowed the model to automatically calculate companies' overall risk exposure and risk probabilities of new projects based on known project variables. Cross-validation and experts validation showed a significant accuracy improvement after data augmentation, achieving over 85% accuracy across various categories. Bayesian network strengths include handling limited data well, providing transparent results to increase experts' engagement, and offering a balanced assessment by integrating multiple data sources. However, they require significant effort and expertise to model complex interdependencies and are context-driven. Coming back to my research objectives, I succeeded to automate the risk management process and to compensate for data limitation using data augmentation and integration of various sources. For risk probability assessment, fuzzy logic models were too risk-averse, deterministic machine learning models underestimated the risks, but Bayesian networks merging various data sources provided balanced prediction and excelled in limited datasets. And for gaining trust, the probabilistic models, due to their transparent white box structure, outperformed the deterministic ones. Hence, Bayesian networks emerged as the final recommended solution, meeting all success criteria and expectations of the industry partner. This research demonstrates the transformative potential of machine learning to automate and optimize risk management in construction projects, addressing key challenges in the industry like data limitations and knowledge transfer. Thank you so much for your attention, and thanks to CIB for giving me this opportunity to share about my research. I would be glad to be connected through LinkedIn or other platforms and answer your questions. Thank you so much.
Thank you very much, Ania, for your presentation. So let's proceed with the next presentation by Dr. De-Graft, Joe Opoku.
Okay, so thank you very much for this opportunity to share my PhD research. I'm De-Graft from Western Sydney University. And I'm going to present on the topic, a methodology for digitally optimizing energy consumption in buildings. So buildings are very significant once we are looking at our daily lives. Once we are confronted with the elements of the weather, the first thing that comes to mind is to enter buildings. Once we enter these buildings, we attend to open doors, close doors, open windows, and then close blinds. And all these create a bit of interaction between the building and its occupants. These interactions then in turn also contribute significantly once we're looking at energy consumption. And there are some evidence to show that, or there's some research to show that buildings are very significant once we're looking at energy consumption that contributes to climate change, which has been something we've always been looking at minimizing. But one other thing that we're always trying to find ways of being able to minimize energy consumption in buildings. But one thing that researchers have not always focused on is the fact that they tend to see the building as a static object rather than looking at it as a dynamic object, because the interactions we have with these buildings then tend to make them dynamic objects. So if you want to be able to optimally minimize how much energy we are consuming in buildings, then we need to look at it from the dynamic perspective. So to be able to capture these interactions between buildings and its occupants, there is a technology that has been making waves in other industries like manufacturing, automobile, and other health sectors. And I then try to look at, okay, so how can I use this technology to capture that dynamic nature of buildings? So for my research, I tend to come up with a methodology that will help me to be able to address energy consumption in buildings optimally by capturing the dynamic nature of buildings, considering technologies like the digital twin and IoT devices usage. So I then wanted to look at the educational sector. And once we come to the educational sector, one particular building that has a bit of interaction between its occupants is the library building. So I picked a library building which is located on Kingswood campus of Western Sydney University for this particular research as my scope. So I developed 5 objectives, and the first one was to look at understanding the key concepts around the research. And then the second one was also to look at the key technology that will be used in this particular research. So for my third one, once I understand these, the next one was to then collect data, looking at that interaction between occupants and the building. The fourth was to use this data to develop the data twin of that particular building, which is in my background. So, and then finally, once I developed the data twin of the library building, which shows me in real time what is going to be the interactions within the buildings, I then came up with some best practice guidelines that would help in improving buildings' energy consumption and also indoor conditions within the building. So to do this, I developed a BIM model of the library building, and then I picked, because of the large scope of the building, I looked at one particular floor and installed sensors to monitor conditions within the building in terms of parameters like heat, light, air quality in this particular building. So within the model, I truncated the model and then tried to show a bit of semiotics in terms of representation of how I'm going to present the conditions being monitored in the library building. And this gives an example of how each of the study rooms that had the sensors installed looks like. So this is a screenshot of the data twin of the library building, and there are set standards for various parameters within any office kind of environment. So this is standards that are from the ASHRAE and other standards within Australia in terms of numbers and the rest, and they give us standards or thresholds on what should be the recommendations within this these standards or these parameters. So looking at this data twin of the building, you realize that all the parameters that were measured were within the thresholds that are acceptable, except for CO2, which is way above what is recommended for comfortable living within buildings.
1 minute left.
So I developed a process model for the implementation of this model that I developed. The significance of this study is that I've been able to show how this technology can be implemented in construction industry, specifically buildings. And then I came up with this best practice guidelines for that particular building. And this is also helping to achieve the 3 sustainable development goals, that is goal 9, goal 11, and goal 13. These are the set of publications that came from my research, and they are published in very high quality impact journals. These are the awards that I received for my study. There are 3 awards from 2022 to 2024. Thank you very much for giving me this chance to present my work.
Thank you very much for your presentation. Let's continue with the next presentation by Dr. Olufisayo Adedokun.
Is my screen visible?
Yes, we can see. You just need to put it on the presentation mode.
Okay, thank you. Thank you once again for having me. The title of my presentation is Incentives for Encouraging Householders Self-Evacuation from Bushfire-Prone Areas in New South Wales, Australia. Bushfire is one of the natural hazards affecting lives and properties globally. An extreme condition like higher temperature, lower humidity, presence of combustible materials are intensifying bushfire risk. In Australia till date, we have experienced over 825 fatality cases in connection with bushfire. And many of these fatality cases are consequent upon householders resulting into either late evacuation or non-evacuation from at-risk regions. For example, during 2009 Black Saturday bushfire in Australia, we recorded 173 fatality cases. Also, during 2019-2020 Black Summer bushfire, we recorded 35 fatality cases in connection with bushfire. All these bushfires, they are catastrophic in nature. Until date, 10 major catastrophic bushfires led to more than 528 casualties, making bushfire to be one of the most difficult situations that we usually experience in Australia. So, based on the prediction of a bushfire researcher, they predicted that in the coming years, there are likelihood of more catastrophic bushfire because of climate change. So if householders should still result into late and non-evacuation, we are going to record more casualties as a result of bushfire. And that is why there's a critical need to address how people make this life-saving evacuation decision. Otherwise, there will be more casualties as we go into the future. So, and that is why my research investigated how incentive can inform householders' self-evacuation decision in response to a severe bushfire threat. In my study, I have 5 objectives. And to address this objective, we adopted qualitative research approach. Why? In order to understand the meanings that these householders, they ascribe to their lived experiences. So, we conducted 30 semi-structured interviews among householders in New South Wales Southeastern region. The reason for choosing this area is because during 2019-2020 bushfire season, these regions were the most affected region during that bushfire. So, and to complement this study, we adopted protection motivation theory as the theoretical lens guiding our research, which focuses on threat and coping appraisal of householders facing an imminent threat. And we complemented this with incentive because incentive can positively change people's behavior when it comes to responding to imminent threats. So using thematic analysis, we analyzed our qualitative data, and in response to objective number 1, we identified 7 major reasons why they chose to live in that bushfire region, ranging from their quest for tree change, proximity to family members, property affordability, and relationship related. Also, when it comes to objective number 2, we identified 7 main themes regarding their level of perception. We assess their perception in terms of severity of bushfire, their level of vulnerability to that hazard, their level of concern, and the likelihood of bushfire occurring in their community, whether they are aware that it's going to occur or not. And we found this perception to range from adequate to very high level. And despite this level of concern or perception, we discovered that during 2019-2020 bushfire season, 53% of the participants evacuated that bushfire-prone area, while 47% of them remain in bushfire risk area trying to defend their building. This implies that there are some factors influencing their decision to engage in this at-risk behavior. And that led us to the 3rd objective, where we identify factors that are actually influencing this at-risk behavior. We found 36 factors. And looking at the patterns and similarities in these factors, we were able to group them into 9 distinct factors influencing at-risk behavior, ranging from health-related factors, rebuilding-related factors, and protection-related factors. While we discovered that all these factors are not in isolation, we discovered 16 pairwise interdependencies among these factors, thereby making self-evacuation decision to be more complex in nature. And to encourage people, we decided to look into incentives that can encourage them from this bushfire-prone area. And in our study, we found 13 major incentives, ranging from availability of information and its timely and effective communication to people that will enhance their evacuation. Emergency accommodation should be provided, availability of financial assistance, security and protection of their property when they are no longer there. Then they should have return access to their property when bushfire subsides. So having identified 13 incentives that can influence these householders, looking at our analysis and interpretation, we discovered that 4 of these incentives can actually influence their level of threat appraisal. And that is one of the decisions they have to make before they decide whether they want to go or they want to remain in the bushfire risk area. And the 13 incentives can actually influence their level of coping appraisal. And when it comes to protection motivation aspect of our framework, we discovered that when householders' threat appraisal is high and coping appraisal is high, householders, they have tendency to self-evacuate. But when threat appraisal is low and coping appraisal is high, they are less likely to leave. But when the threat appraisal is low and coping appraisal is low, they have tendency not to evacuate. And looking at emergency responders and the policymakers, they are interested in people evacuating bushfire-prone area before it becomes imminent. So to do this, the threat and coping appraisal of these householders must be enhanced. And how do we enhance it? Looking at this framework from right-hand side to left-hand side, we have been able to identify the incentive that can actually enhance threat appraisal level and coping appraisal of this householder. And if you look at it critically, we said these 4 incentives can influence threat appraisal, while all the 13 incentives can influence coping appraisal. So if all these incentives are made available for householders in terms of information, in terms of resourcing, rural fire service, emergency accommodation, their threat and coping appraisal level can be enhanced. Thereby,
1
they will have
minute left.
tendency to self-evacuate. So the practical implication of my study is that it reduces fatality and losses in bushfire-prone areas, while also providing clear guidance on resource allocation and community engagement strategies for pre-disaster preparation. It serves as a model for assessing evacuation incentive in other disaster-prone areas. And in conclusion, our innovative incentive-based framework enhances understanding of self-evacuation decisions, thereby making policymakers, aiding policymakers in disaster preparedness. In future, we anticipate to apply this framework in diverse geographical locations, while we also continue our engagement with disaster resilience stakeholders. These are some of the outputs from the research, and I want to thank you for giving me this opportunity to share my research with you.
Thank you very much, Olufisayo, for your presentation. So let's continue with the last but not least presentation by Oluleye Benjamin.
Can you see my screen?
Yes. Not yet.
Can you see my screen now?
No, not yet. We can see you, but not the screen yet. Now something is appearing. Yes, we can see it now.
Please. Okay, my name is
Could you put it on the present? Yes, perfect. Please continue.
My name is Benjamin from Hong Kong Polytechnic University, and I'll be presenting my the findings of my PhD on assessment model and decision support system for the adoption and implementation of circular economy in the building construction industry. As we all know, the construction industry plays a critical role in every nation as it promotes GDP and it creates employment. But this role doesn't come cheap. They come at a price. For example, the industry is responsible for high consumption of resources. The waste generation is very high, and the environmental impact in this industry is on the high side. This shows that this industry is rooted in a linear economy. What do I mean by linear economy? It's a system that make and dispose materials at the end of life. This system is not sustainable. And because Earth has given us a free meal, there's a need for us to control our appetite. How do we go about this? That is why we have the circular economy to help us to control our appetite in the construction industry. The circular economy ensures that we have a circular design, we have the necessary conditions, the revised cycle, and necessary business model to ensure that there is ease of reusability at the end of life. This takes me to some of the research problems I identified in my study. I looked at the problem from an international perspective and from a contextual perspective. There is a limited research on CE from the international perspective, and also in Nigeria, which is a typical developing economy. There's limited research in this area, especially we don't have the appropriate distribution model, and there is no decision-making system to enable circular economy in the construction industry. So why do I look? This is the research scope for this study. I look at the macro level, the micro level, and the nano level, which is the various level of circular economy. I also look at circular economy from an international level. I went ahead to look at what is happening in Nigeria by investigating circularity in construction industry of Nigeria. And these are the reasons why I choose Nigeria for my study. So moving ahead, this is the research aim of my study, and this aim is guided by 5 different research objectives. I looked at the barriers and success factor from an international perspective. I also look at this also from Nigeria perspective and develop a data-driven hybrid model for predicting the evolution of circular economy. And I integrated LCA and PBLCI for looking at the impact level and the circularity level of a difficult commercial building in Nigeria, and I developed an automated knowledge-based decision support system for circular economy, the construction industry of Nigeria. This is the data analysis and the research approach. The first objective and the second objective, I used the FSC approach to develop the model, while the third objective, I used the PLSM and the classification machine learning algorithm for the data-driven model development. Well, for the fourth objective, I integrated lifecycle assessment cradle to cradle with PBLCI to be able to take decision when looking at the circularity level and the impact potential of material. And the final objective, I used the FSC and the Streamlit framework for developing an automated knowledge-based decision support system for circular economy. For the first objective, I was able to find out that we have specific barriers and generic barriers when we are looking at developed and developing economy. That means we need to be context conscious when implementing circular economy. And for the second also looking at the context, looking at the international perspective, I was able to develop two models, a model for the developed economy and a model for the developing economy that will guide circular economy adoption and implementation. And in the Nigeria case as well, I was able to develop model for the success factor and the model for barriers that will guide circular economy in Nigeria. So for the third objective, I was able to integrate the PLSM and the machine learning. And for the PLSM, I was able to find out that we have 4 factors that actually influences circular economy dilution. But I need to understand the contribution of this factor. First, I was able to figure out that the random forest is the best model because it performed well when we look at the MCC and the ROC AUC. But I would need to understand which feature contribute most to this model. Then I used the sharp additive to be able to know the model, the features that contribute most. I was able to find out that 3 features out of the various features that I investigated contributed more to this particular model. Moving ahead to the third objective now, I had to look at a case building in Nigeria to see what is actually happening in terms of the development of what they are doing. So I looked at the various scenarios and I was able to look at the circularity of this building. Looking at the various scenario 2 has the best circularity, but we can't take decision only based on circularity. We have to look at the impact potential. So I looked at the impact potential using the endpoint result. Scenario 2 has the least impact potential. And looking at the ozone layer depletion and global warming potential, scenario 2 also has the least potential. What does this mean? Then that means that scenario 2 should be decision making when it comes to circularity and impact potential. Action should be taken and decision makers should make sure that they follow the scenario 2 because it has the highest circularity and the least impact potential during their construction. So that takes me to the final objective, which is developing a knowledge-based decision support system for circular economy adoption. In this case, I use a Streamlit framework for the back end and the front end for developing the automated knowledge-based decision support system. This is the cover page of the knowledge-based decision support system, and it was validated by experts. I mean, using the case building, and this is like an automated report. We could see that the project has low propensity for circularity. Because of this, action plan was automated for them so that it will guide their circularity decision making. Conclusion and overall contribution. I was able to come up with mechanisms that will facilitate circular economy adoption. Like I said earlier, I was able to come up with a model that will help us to control our appetite in the construction industry, both for the international perspective and the Nigerian perspective. I was able to also come up with an automated knowledge-based decision support system for guiding circular economy decision-making. And I was able also to look at decision-making based on the impact potential and the circularity of material in the construction industry of Nigeria. And I was able to also develop a dilution model that can help in predicting circular economy in the construction industry of Nigeria, which was appropriately interpreted using the sharp additive. So the practical contribution of my study. This study has developed a model that could assist government and stakeholders in resources allocation. It has also come up with a data-driven approach for stakeholders in predicting circular economic dilution. And most importantly, it provides guidelines for product designers to evaluate circularity level and impact potential. And the KBDSA, which is knowledge-based decision support system, will guide project team in early stage of circularity to align their project with CIB principles. These are some of the publications directly from my PhD, and I have 3 papers under review at the moment, and all these journals, they are Q1 journals. Thank you very much for giving me the opportunity to present my research to you. I appreciate this opportunity. Thank you very much.
Thank you very much for your presentation. Thank you to all of our finalists for their great presentations. I will now create a breakout room in which our judges will confer privately to select the winner, and I will join them. And while we are there, Ira will kindly keep the discussion going with our finalists with some general questions. And we will be back shortly. Ira?
Yeah, thanks, Sina. I'll let you create your room before we continue.
I have done already, so you can
Okay.
go ahead.
Yeah. Thanks all for your really interesting presentations. As some of you will be aware that we asked all the shortlisted candidates to create a short video just to outline their research in 2 minutes. Really, the idea being that if you bumped into somebody in the street, you could explain your research quick and simple without any slides or anything. And I have to say, we were, generally really pleased with the videos that we received. So my sort of questions really are more around the communication of your research, because obviously, obviously with research, there's some really complex data and graphs and charts and everything. Can I ask what are the difficulties you think you might have come across in trying to, and I don't want to use the word simplify your research, because I don't think that's what you're doing, what anybody is doing. I said, but it's more in making your research accessible to anybody. So what sort of difficulties would you say you've come across? And maybe Anya, I can start with you, because I know you've previously recorded some videos for us, so you've had a little bit of experience with this. But if we start with you, and then
Sure.
just go around everybody then.
I'd love to. Thank you, Ira. Yeah, I think I recorded a bunch of them for you before. But yeah, this was actually a very interesting challenge. I had the very same challenge during my PhD, because my PhD was an industrial PhD, and I was directly working with industry partners that were not familiar with my domain. I was doing like AI-based research, but many practitioners in our industry are not very familiar with the terminologies and the workflows of AI and everything. So I personally encountered that communication challenge and issues to building, a common understanding with the audience that you're working with. It could be your, let's say, your professional audience with who you're working, or could be a broader audience of people at the university or the followers on LinkedIn or whatsoever. Definitely, it is important to, in my opinion, to know what the main message of your research is, because at the end of the day, if any of us need to shrink down the essence, the main contribution of our research, we know it deep down, but it needs a little bit work and a little bit of understanding that what the main essence is, and then try to build on it. Otherwise, we can get caught up in bringing up many details and intricacies of our research, which is probably understandable for us or for our supervisor, for our research team, but not for other people, even in our domain. So, but I would say it's an important skill as a researcher to develop, because at the end of the day, we want to gain exposure. We want our research to be seen and to be understood and cited by others. So I guess it is a definitely very important skill to build as a researcher. And I guess it was a very nice exercise and challenge you invited us to do. And thanks for that.
Yeah, I think that's a really good response, actually, you've given there. And It's not something we've decided yet, but we are thinking that and I'm not sure whether I should say this or not, but I will anyway, that we are thinking of that possibly next year that we actually will make it part of the judging criteria. Because as you say, it is vital that, you know, our researchers and academics are able to talk and explain their research to a much wider, much broader audience in order to engage, you know, as I say, with a broad audience. So thanks very much for that. Should we go, De-Graft, how about you?
Ira, can you hear me?
Yes, we can hear you.
Yeah, thank you very much. Similar to what Anya mentioned earlier, I think I did a bit of technology inclined kind of research, and it becomes a bit difficult or challenging once you are trying to communicate some of these things to people outside. For those in academia, it's sometimes a bit easier, but getting to explain the terminologies and how the concepts work becomes a bit of challenge once you're talking to somebody who has no idea in terms of applications of technology. So one thing that's helped me mostly here throughout my research is here in Australia, we have what they call 3-minute thesis, where you explain your research to somebody who has like a lay person. So you try to give a summary of your work in 3 minutes, and doing such things, it really gave me an idea of how do I try to explain things. Although I'm publishing my work in high quality journals, people are getting access to the information I'm communicating. But if I get to a layman, how does he also understand these concepts? So that is why I try to make it so simple. Even you could see that in my presentation, it's something I developed throughout my 3-minute thesis presentation once I was doing my research. So that was one of the challenges I had throughout doing this work.
Mm-hmm. Yeah, that's good actually. And as you say, it's understanding the terms that you're using as well, isn't it? You know, we can have the same. You know, we could. I'm just trying to think of the word positive can have a very different meaning to a lay person to somebody who's doing research. Whereas, you know, it's that need to be sure that everybody understands the terms that you're using and their reference within the work that you're doing. So thanks for that. Honey, how about you?
Hi. Yeah. So I've also heard about the 3-minute presentation, but I didn't have the chance to do that. But for the video, I think it's a great opportunity, and I'm kind of think like I'm doing a very small TED talk to talk to the audience who didn't know anything about our research, and but I try to explain and also try to really convey my key contribution of my research to the society and also to the public to show what's the contribution to our like to our future, to our sustainable society, something like that. But also try to explain more about the same, like I'm doing the BIPV, but I won't tell you that it's the technical thing about the BIPV. I just want to tell you that it can actualize the facade and also try to generate the energy, and just give this a simple concept about this, and also want to show them a kind of simple idea about how it can help to make our society more sustainable. And I think they are more interesting about the economic part. As we talk with the stakeholder, they have they have very limited idea about the BIPV, but they have a lot of concern about this product. So we talk about it with the urban planner, also the architects, and so we got the general idea about how they understand about these products. although they are all people from the building industry, they have a very limited idea about this. So that's what I got the experience about how to really communicate with the different stakeholder. And also I try to explain my research with my parents, and they also have very limited idea about what I'm doing, but I just want to tell them my work is very important.
Yeah,
So
that is a great example, because I've done a lot of work with researchers and trying to help them, you know, communicate their research, and trying to get people to, you know, pitch it at just the right level, so that you know, it doesn't matter who they're speaking to. And a researcher said to me, "Do you mean as if I'm speaking to my grandmother?" And we said, "Yes. If you do that, you know that everybody will understand what you're talking about. No disrespect to anybody's grandmother. But you know, it's then a good place to start, because if it turns out that that someone is very knowledgeable about the subject that you're talking about, that's great. You can take it from there. But if they're not, and you start at a very high level, you know, you've lost them. So thanks. That's a really good example there. So now we're doing a quick round on you know, how they found or difficulties maybe in communicating with a wider audience. We've got 2 to go.
Okay.
Have we got time, or do we need to move on?
Yeah, if you can make it quick.
If we're quick,
yeah.
okay then. Who should we go to? Officer, or do you? How about you?
Thank you. I quite agree with what you said. One of my advisors used to say that if you are able to convince your grandmother, or maybe a year 6 primary school student, if you are able to communicate your research to them and they understand, everybody should be able to understand your research. So like in my own case, there are some terminologies that academics can easily understand. We are talking of evacuation, non-evacuation. But if you want to interview people, you have to come down to their level. Do you want to stay or do you want to leave, rather than using evacuation, non-evacuation? But unlike other researchers, maybe those that are working on green building, AI and stuff like that, you can collect your data anytime. But in my own case, being a bushfire research, we are constrained as to the time you can interview people. You don't want to go there when they just experience bushfire in order not to traumatize them again. So you have to strike a balance. You have to meet them before bushfire commences or shortly after bushfire must have passed them. So that's the kind of challenge. There's no flexibility as to going to people and just collect your data anytime you want to do it. You have to take people into consideration when you want to collect your data and give them enough time so that they won't be traumatized with your research.
Yeah, that's great. That's and the one thing I've really enjoyed about this evening and the reason is that your topics are just so broad. It's you know, it's just really interesting. And then so if we could quickly, Benjamin, if we can come to you.
I think one of the major problem, I agree with other people as well, what they've said. I also encounter similar problem, but we also like to talk about, I find it difficult to explain because people see recycling as circular economy. And I used to tell people that recycling is just one of the principles and one of the aspects of circular economy. So when I say circular economy, they say, is it the same thing as recycling? I will tell them no, but recycling is also circular economy, but it's one aspect. So it was quite difficult to convince people, because they see circular economy to be recycling, to understand what circularity actually is. But along the line, I was able to find a way through, because I was able to explain in details to some of these people. And other things that I was able, I also participated in the 3 minutes thesis presentation in my school, and that was a very good avenue for me to also communicate my research to people in few minutes. So I had better understanding on how to communicate and how to convince people to understand my research. But one thing that helped me is in my research group, there's this thing that we always do. You have to use a marker to, draw something to illustrate your research using a diagram, just using a marker on the board. So we do that. And if you're unable to do that, then that means you don't really understand what you are doing. So just draw some diagrams so that, okay, once anybody see this is going to this is going to that, and at the end of the day, we are going to have this. So that actually helped me to be able to communicate my research better. Thank you.
Mm-hmm. Yeah, that's great. That's you know, I think it's quite you've all sort of mentioned similar problems, but or not problems, but you know, steps to overcome then. But all within your different fields of research. So thanks very much for that. And I really would encourage you all to carry on. You know, if you ever get any opportunities to record short videos or to talk to a wider audience beyond your you know, beyond your actual research networks, then please do that, because it is just so important that we're able to communicate our research to a broad audience. So thanks very much to you all. Sina?
Okay, thank you very much, Ira. So, yes, we are back. We had 4 criteria for evaluating and selecting the winner. The criteria were language, methodology, importance of topic, and contribution to the theory and practice. So I would like to really highlight that the competition was really tough, as you were all great. And but based on the scores of our judges to your presentations and to your dissertation, I am pleased to announce that the winner of CIB Best Doctoral Dissertation Award 2024 is Honyang Zhao. Congratulations.
Me? Me, really? Thank you very much. Sorry, it's 5. It's almost 6 in the morning. I'm still kind of shocked.
Congratulations. Now I would like to invite our judges, each of them, to say something about you know, your thesis and their opinion. Yes, please. Kalle, you may go first.
Okay, thank you. And first of all, my warmest congratulations, Hong Jin Zhao, to you for this award achievement. Well, when I started to watch this presentation, and you were the first presenter, so I thought that, well, it seems that the quality of these presentations are very high, and but it was also your presentation. What I liked there, and what I liked of your research, is a kind of clear focus in together with a kind of overall larger perspective, to have a focus on building integrated photovoltaic systems. So I think it was great, and it is also very helpful to have and think about this kind of driving force that is needed in a way. So, and well, on the other hand, your presentation, it was followed by 4 other top-level presentations, and I quite enjoyed those as well. So my warmest congratulations to you, Dr. Zhao, and my warmest congratulations to all finalists of this competition.
Thank you very much, dear Kalle. Kathy, you may go next.
Thank you, Sina. So first of all, congratulations, Hongqing Zhao. Well done. Very, very interesting study. What swayed me, sorry, everybody else, is the absolute clear alignment and the focus of your PhD on a commitment to sustainable cities and the SDGs. And then on top of that, you did an absolutely fantastic job. Just to reiterate what Sina said, it was incredibly close, like down to 2 decimal points. So please don't be disheartened, the other 4 of you, the rest of you. Your work is absolutely incredible in each of your individual fields, and thoroughly enjoyed listening to the little highlights that we got in the 6 minutes, but I also did enjoy a quick scroll through your PhDs. Thank you, Sina. Actually, shared them all with us. You've all done absolutely amazing work and an incredible contribution to the body of knowledge in your each individual area. So please carry on doing the amazing work that you are doing. And yeah, just enjoy the research, and congratulations actually to all of you for making it through to this particular panel, and very special congrats to Zhongling. I know RMIT are going to celebrate big time with this one.
Thank you, Katie. Jeremy?
Yes. Thank you, Sina. I think congratulations to everybody. It's difficult to get through, I think, to this stage, and it's you know, definitely a lot of work that you've all put into the presentation. I think maybe to start off with, just broadly, what struck me was that all of you had very practical, applied research topics. Circular economy, fire, risk, renewable energy, IoT systems, digital twins, etc. And they're really current major issues. You know, the area I work in is sustainable buildings, smart, sustainable built environments. And those are really the topics that are current. So it was very nice to see them coming through as kind of very strong areas of work. And I hope you all pursue them and carry on in your different fields, because I think they are the key issues. So that's the first thing, is really applied important topics using current thinking, using the latest technology, AI. So fantastic topics and methodologies as well. I think, again, as the other judges have said, it was close. But I think there were a couple of things really in terms of the winner that kind of pushed her topic maybe perhaps a little bit further. One was obviously, again, very practical, very applied issue. And you can imagine this in most cities currently, wherever you are, Johannesburg, Perth, London, it is a major issue. How do you look at renewable energy on these buildings that are constantly changing? You've got different shadow patterns of neighboring buildings. So it's an incredibly complex and really interesting topic. And I think the rigor that she pursued with it, and in the end, coming through to the end, I think one of the key things for me with PhDs is that it's very useful to be able to get to within kind of striking distance of an application, and I felt very much with that particular topic and bit of work was, you know, it's something that can be fairly easily developed into a system and applied in different cities, etc. So that kind of just helped push your particular PhD, I think, that last little bit. So I think that's it really from my side. Just congratulations to everyone, and, you know, brilliant pieces of work, and thank you very much for presenting it and the conversation. Thank you.
Thank you very much, dear Jeremy. In addition to our warmest congratulations to the winner, as a tradition in this award, we also select 2 top runners. And based on the average scores of our judges, I would like to congratulate Benjamin Olule and Ania Khodabakhshian as the 2 top runners in this competition. Congratulations to you as well. And just to highlight again how close was this competition, you both achieved the same average score. So this was really, really close. And congratulations again to all of you. And I